Welcome to our explanation of Ohm's law, a fundamental principle in electrical circuits. This law was first introduced by George Simon Ohm in 1827 and describes the relationship between voltage, current, and resistance. It is expressed as V equals I times R, where voltage, V, equals current, I, multiplied by resistance, R. In simpler terms, voltage is the electric potential difference that pushes electrons through a circuit, represented by the letter V. Current, indicated by I, is the flow of electric charge, how many electrons move through the wire per second. Meanwhile, resistance, shown as R, opposes the flow of current, acting like a bottleneck. A useful analogy is imagining water flowing through a pipe. Voltage is the pressure pushing the water, current is the volume of water flowing, and resistance is the pipe's narrowness. The greater the resistance, the harder it is for electricity to flow. Applying Ohm's law to a practical example, consider a circuit with a voltage of 20 volts and a resistor of 10 ohms. To find the current, rearrange the formula to I equals V/R, giving us 2 amps, 20 volts divided by 10 ohms. In another example, with a voltage of 9 volts and resistance of 3 ohms, the current would be 3 amps. Ohm's law finds application beyond textbook exercises. Engineers and technicians employ it in designing circuits for various gadgets, including phones and cars. It aids in determining the proper resistor for an LED to avoid burnout, and in troubleshooting wiring issues by measuring voltage and current to identify resistance problems. To avoid common mistakes, ensure the use of correct units: volts, V, for voltage, amperes, A for current, and ohms, ohm symbol for resistance. Remember, voltage causes current to flow, not the reverse. For rearranging the formula, use the Ohm's law triangle: V at the top, I, and R at the base. This simple tool simplifies calculations, even in complex circuits. In summary, Ohm's law is an essential tool whether you're constructing a robot, repairing a circuit, or studying for an exam. Its practical applications make it invaluable in understanding electricity.